All right, guys, so this is section 4.1, and this is the start of chapter 4. Now we're going to break chapter 4 into two smaller chapters. So we're going to do 4.1 through 4.4, and then we're going to take a 100-point test, and then we're going to do the second half of chapter 4 and take another 100-point test. Okay, so today's lesson's all about just some general polynomial stuff, and a lot of it you've seen before, a lot of it might be new. So real quick, just to kind of get your brains going, I want you to think, and you are going to have to think some, and try to do your best to match each one of these graphs with the correct equation. Okay, and then we'll come back and we'll talk about it. So go ahead and pause this and do that. All right, so this is what you should have gotten. Now, I matched the graph with the equation and the equation to the graph. So depending on how you do it, you should be able to see how well you did. So just kind of as a reminder, x cubed, if I were to graph that, it looks something like this. Okay, and then x to the fourth looks pretty similar to x squared, but it's a little bit flatter on the bottom. Okay, so it looks something like that. Now, these are positive x squared, so that would mean a negative x cubed would look like this, and a negative x to the fourth would look like that. Okay, so keep that in mind. So that should make you be able to, I guess, match most of these. Now, the only difference is if you look at like D and E, okay, nope, not D and E. If you look at E and A, so A and E, okay, these look pretty similar. So they're both a positive x cubed. Okay, obviously, both of these are positive x cubed. The difference is this is more wonky and this is more just plain Jane. Okay, well, when it's plain Jane, notice we don't have any added stuff, but when it's more wonky, we have more wonky stuff in the equation. Okay, so that's just a quick way to do it. All right, so these should all be review for you, this part here. And it just talks about some polynomial functions. So remember the degree, this is going to be the highest exponent. Okay, so like last chapter, everything was squared. We did quadratics because it had a degree of 2. Okay, so a degree of 0, guys, is just a constant. A degree of 1 means the highest power of the function is 1. So just 5x to the first or just 5x. That's a linear. Quadratic is 2. Cubic is 3 and quartic is 4. Okay, and we're going to be getting into some of these bigger ones this chapter. When we write these, I guess if we start here, a polynomial is a monomial or sum of monomials, meaning like this is a monomial, this is a monomial, this is a monomial. Okay, all these terms are monomials. Okay, and polynomials when we have one or more put together. Okay, a polynomial in standard form is when the terms are written in descending order. So we're starting with the highest to the lowest. So remember we had ax squared plus bx plus c. If I took the extra time and I put, that's x to the first, and we could write that as x to the 0, because remember x to the 0 is just 1. We do write quadratics with the greatest to least exponent. It's the same thing with any of these polynomials. We always write it from greatest to least. All right, so if we look at example 1, okay, this tells us to do a few things. So first, we have to decide whether or not this is a polynomial function. If it is, we want to write it in standard form, and then we want to state its degree, its type, and the leading coefficient. So we'll talk about each of those when we get there. Okay, so this here, it absolutely is a polynomial because each one of these are monomials. Okay, so yes, it is a polynomial. Okay, standard form would be greatest to least coefficients. Well, this is x to the third. This is like x to the first. This is like x to the 0. So this is already in standard form. Okay, now when it says to state its degree, once again, the degree is the highest exponent. So our degree here is 3. Okay, and when it says type, we get the type from the degree. Now we know that anything to the third degree is a cubic function. Okay, so those kind of go together. So that's the type. Type is cubic. And the leading coefficient. The leading coefficient, guys, is the coefficient in front of the highest power. So the leading coefficient here is a -2. All right, so if we look at B, first we want to decide, is it a polynomial function, where this is a monomial, this is a monomial, and this is a monomial. So yes, this is a polynomial function. Okay, then we want to write it in standard form, or we want to write it in decreasing order. So notice this is our highest exponent, and it is not at the very beginning. So we're going to rewrite this as g of x equals, now notice the square root of 2 is only over the square root. The square root is not over the x to the 4th. Okay, so square root of 2 outside of the square root is x to the 4th. Okay, the next highest exponent is 0.8 x cubed, and then we have a -12. Okay, so this would be in standard form. Okay, now our degree is our highest exponent, so we have a degree of 3. And because we have a degree of 3, oh, sorry, a degree of 4, my bad. We have a degree of 4. And because we have a degree of 4, that means this is a quartic function. Okay, and my leading coefficient would be the coefficient of that exponent. So leading coefficient is square root of 2. All right, let's look at C here. Okay, first we want to decide, is this a polynomial function? So if I look at this, this is a monomial. This is not. And the reason it's not is because we have a negative exponent. So not a polynomial function. Okay, this negative exponent screws it up. Now remember, a negative exponent, and we'll have a whole chapter here second semester, the x to the -1 is the same thing as 1 over x, so that's actually a rational function. Okay, you don't need to know that right now, but we'll get into it later. All right, if I look at D here, okay, once again, I'm trying to decide, is this a polynomial function? Well, my x squared is definitely a monomial, but my 3 to the x power makes this to where it's not a polynomial. Okay, and once again, we will get to the second semester, but we would call this an exponential function. And we'll learn all about those later in the year. All right, guys, so here is 4 graphs that I don't want you to memorize these. I want you to understand them, okay? That way you don't have to recall them later, okay? It's just automatic. So the end behavior of polynomial functions, okay? Anytime we have an odd degree, we go bottom left to top right, okay? So it could look like that. It could look like this, okay? It could look like whatever, but we're going from the bottom left of the graph to the top right of the graph, okay? That's if we have a positive leading coefficient, okay? When we have a negative leading coefficient, okay, we get a graph that looks like this, okay? So if it's linear, it can be this way, or if it's cubic or whatever, it can be this way. Okay, it starts at the top left and it goes to the bottom right. Okay, always, that never changes. All you need to know is if the degree is even or odd, or if the leading coefficient is positive or negative. Okay, same thing down here. If it's even, okay, if it's even, we are going to start at the top left, go down, and end at the top right. That's if we have a positive leading coefficient. Okay, but if our A value is negative, okay, we're still going to do this, but it's going to be flipped. So this would be even with negative leading coefficient. And here we're starting, if I put a coordinate grid on here, here we're starting at the bottom left and we're ending in the bottom right. Okay, so if you know just the general shapes of these, this next part should be easy. All right, so if I look at example 2, it says describe the end behavior of the graph. We're eventually going to be able to graph this whole thing. But right now we're only concerned about the end behavior. That means, you know, to the very, very, very left and to the very, very right, even, you know, beyond the graph. Okay, so all we need to look for is if degree is odd or even, and we need to know if the leading coefficient is positive or negative. Okay, so if I look at part A here, my my degree is 4, which is even. Okay, so that tells me my graph is either going to do this or it's going to do this, one of the two. It might be kind of blah, blah, in the middle, but we're just concerned about the ends right here. Okay, now this leading coefficient is what tells us which way it goes, and the leading coefficient is negative. And therefore, this is what our graph looks like. Okay, so if we put this on a coordinate grid, okay, maybe it looks like that. It doesn't really matter. Okay, the way we write this is we have two ends. We have when x goes all the way to negative infinity, and then we have when x goes all the way to positive infinity. Okay, so we're going to write this as x goes to negative infinity, f of x, remember, f of x is equal to y. So as x goes to negative infinity, f of x goes to, now think of it this way, as x goes more and more and more left towards negative infinity, this y value is going to go more and more and more down, so it's going to go to negative infinity as well. Okay, so that's one part of it. And then we have the other part when x goes to positive infinity. So as x goes to positive infinity, comma, f of x, or y, now once again, as we keep going to the right, we're also keep going down, 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 towards negative infinity again. Oops, not negative 8, negative infinity. So this would be how we'd write our end behavior of this graph. All right, let's look at B now. Okay, so once again, we're just doing the end behavior. So what we have is we need to look for the degree. Okay, we have a degree of 3, which is odd. Okay, so that tells me I'm either going to do this or I'm going to do this. See, this is where I say we don't have to memorize, just know what it means. Okay, so this would be when we have a negative leading coefficient, and this would be when we have a positive leading coefficient. Okay, so if we look, we do have a negative leading coefficient, which means the graph we're looking for is like this. Okay, so once again, we're going to do the two scenarios. Okay, we're going to say as x goes to negative infinity, okay, so as we go to negative infinity, we're going left, 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 left. So this keeps going left. My y value, or my f of x, continues to go up and up and up and up and increases. So as x goes to negative infinity, my y is going to go to positive infinity. Okay, up is positive. And then as my x goes to positive infinity, okay, so here when x goes to positive infinity, think of that as your x is getting bigger and bigger and bigger, so we're going right and right and right and right and right. So as this continues going right, my y value continues going down, 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 down. So my y value, or my f of x, would be going to negative infinity. And this would be my answer. All right, I encourage you to start and do these monitoring progress. Go ahead and pause it, do these if you need to, and then I'll go over the answers. All right, so if you did these monitoring progress, this is what you should have gotten.